Physics Part 333. Another Nelson. Triple Nelson. Grasp the coil or solenoid in the right hand with the fingers pointing in the direction of the current. The thumb gives the direction of the magnetic field. The magnetic north end of the coil or solenoid is the end from which the lines of the magnetic force are emerging. Note the similarities and, more importantly, the differences between this rule and the right-hand rule for the long straight wire. Uniform magnetic fields are of importance in the study of charged particles. A uniform field is produced in a solenoid, but this field is inside the solenoid, and consequently it may be difficult to make observations and to take measurements. This problem is overcome by using Helmholtz coils. These are two identical flat coils with the same current in each. The coils are positioned so that their planes are parallel and separated by a distance equal to the radius of either coil. The coils and their resultant magnetic field are illustrated in the figure. We've got an example for you. Two long straight wires of circular cross sections are each carrying the same current directly away from you. Down into the page drop the magnetic field due to the two current carrying wires. Now it's your turn. Number one, draw a magnetic field pattern, one in each case to represent a uniform field, a field which is decreasing in the strength in the direction of the field, a field which is increasing in strength along the direction of the field. Draw a diagram of the magnetic field due to two long straight wires when the currents in the two wires are in opposite direction. Electromagnets and their uses. The strength of the magnetic field due to flat coil or solenoid may be increased by the winding in the coil or on a bar of soft iron. The bar is said to be the core of the coil. The iron is referred to as being soft because it can be magnetized and demagnetized easily. With such a core, the strength of the magnetic field may be increased up to 1000 times. With ferrous alloys, iron alloyed with cobalt or nickel, the field may be 10 part raised to 4 times stronger. Magnets such as these are called electromagnets. Electromagnets have many uses because, unlike a permanent magnet, the magnetic field can be switched off by switching off the current in the coil. We've got a section summary for you. Number one, a magnetic field is a region of space where a magnet will experience forces. Number two, magnetic field lines never touch or cross. Number three, separation of magnetic field lines indicating the strength of the magnetic field. Number four, an electric current gives rise to a magnetic field, the strength and direction of which depends on the size of the current and the shape of the current carrying conductor. Number six, the direction of the field due to a straight wire is given by the right-hand rule. Number six, the direction